All right, so let's wait for, I guess, a few more moments to see if the additional attendees will add in. Otherwise, I think we'll just get started.
Yeah, we got one attendee join.
All right.
Guys, let's go.
Okay. All right. Hello, everyone. Good morning, good afternoon, good evening, and good night, wherever in the world you are. My name is Samir Warukar, and today we will be presenting Don't Wrestle with Your Data, the what, why, and how of data wrangling. So before we jump into today's topic, we'd like to first thank you guys all for attending and let you guys know that today's webinar is the first in a three-part series on the subject of data wrangling. Today's webinar will be covering the topic of sampling and exploring your data. The webinar that we have on the 11th of May will be covering the cleansing, reordering, and evaluation of your data as part of the data wrangling process. And finally, on the 14th, we will be covering the testing, analysis, and retesting of your data for the data wrangling process. So first order of business, we want to just give you some introductions to myself and my fellow my fellow presenter Pratik, as well as giving you a quick overview of our company, Express Analytics. So as I said, my name is Samir Warudkar. I am the project engineering head for Express Analytics in their Oyster CDP project. Pratik, why don't you go ahead and introduce yourself as well?
So hello everybody, my name is Pratik Bhurke. I am a data analyst with Express Analytics, and I have a background in personal management and training and even teaching. So I also conduct trainings with Express Analytics.
Thanks, Pratik. So let's quickly give some background on our company. Express Analytics is a marketing analytics and business intelligence company that was founded in 1999 by some big five managers. Our core competency is in data science and business intelligence, and we've offered a number of solutions over our 20-year tenure that includes implementations of projects in Informatica, Tableau, and SAS for clients that include Walmart, Lamps Plus, Solar Turbines, and Western Digital. But let's focus in more on the topic of the day, which is the data wrangling process. So we're going to start with a discussion of data sampling, what it is, why it's important to the data analytics process, and how it can be achieved. And then we're going to follow up with a similar exploration of data exploration. So I'm going to hand things off to Pratik so that we can present on data sampling. Pratik, go ahead.
Thank you, Samir. So when we talk about sampling, the first thing that comes into mind is to take a small sample of something, right? So sampling is basically taking a small piece of a larger whole in order to study it. So as you can see, basically it is about collecting data about the population that we wish to study, right? That basically is data sampling. Why do we do it? It is also to choose observations that we wish to analyze out of our data set, right? So why do we do this? How do we do this? Let's take a look at that on the next slide. So why is data sampling necessary? Well, first of all, few reasons. Firstly, population data is very, very difficult to collect. To give you an example, Google, which collects data on all of its users, still does not have population data because a lot of internet users are not a part of the Google ecosystem, and a lot of people themselves are not even on the internet. So even a company like Google, which could have possibly all the data, doesn't necessarily have population data. The closest thing we can get to is to make an assumption of what the population parameters look like depending on our sampling. Secondly, sampling enables us to focus on that segment which we are interested in and ignore all of the rest. Finally, it is important because it reduces the data size, right? To give you an example, some of our SQL queries, which draw on thousands and thousands of records, can sometimes take up to 20 minutes to run. And this is just to get the record. So if we actually pump all of this into a model, it could take hours and hours and hours to run on a very, very fast and high-end computer. So to make the modeling process a little faster and a little simpler, it is helpful to reduce the data size. So by sampling, we pick a few observations to represent the whole, and then we are able to reduce the speed, the time required to run the model with a very little trade-off to the accuracy of the model, right? So that is why sampling is necessary. Let us now look at the different kinds of sampling which are available to us. So there are 5 main kinds of sampling. The first is the random sampling. Then we have a systematic sampling, clustered sampling, segmentation, and finally we have what is known as the complex sampling. Let us now take a look at random sampling. The most common example I can think of random sampling is when someone holds up a pack of cards to you and asks you to pick a card randomly, right? So as you can see here, we have a pack of cards and we're going to randomly pick 4 cards. No logic to it, just first 4 cards we like, we just pick them. Okay, as you can see, we have now randomly picked 4 cards, and now this is our random sample. Now it is important during random sampling that your data set that you are picking observations from is more or less homogeneous, as in the elements are similar to each other in most of their properties, and that there are no clear demarcations or groups in your data. Secondly, it is also important to make sure that you have picked enough elements out of your sample, because it is like expecting a coin to give you one head and one tail if you flip it twice. It's not always going to happen, but it is more likely that you will get around 50 heads and 50 tails if you flip a coin 100 times, right? Same principle. The more number of samples you pick, the more accurately your sample will represent the population. So that right there, ladies and gentlemen, was random sampling. Let us now look at systematic sampling. So let us take our deck of cards again, except this time I am going to pick the cards in a certain order. So I'm going to pick the first card, then I'm going to skip 3, pick the next card, skip 3, pick a card, skip 3, pick a card, and so on and so forth. As you can see, after the first card, I have picked every 4th card. Okay, and this right here is systematic sampling. Now, one thing to keep in mind when we are using systematic sampling is to make sure that your data set is not ordered along any variable, right? Because otherwise you can have skewed results. For example, if I pick the numbers 1, 5, 9, the average I'm going to get is 5. But if I pick the numbers 2, 6, and 10, the average I'm going to get is 6. So you see, by deciding which element to pick, the results we get can be slightly different. All right. So this is systematic sampling, which should be used only if your data set is randomly ordered and is not in any particular ascending or descending order. Okay. Now let us look at what is clustered sampling. Clustered sampling, quite simply, is where you group the data into clusters and then you have to examine clusters individually. So as you can see here, we had 12 data points which have been grouped into 3 clusters. All right. So now in each cluster, the data points are similar to each other to be in one cluster, but are dissimilar from other points to be in a cluster of their own, right? So depending on how much similarity or dissimilarity points have, clustered sampling works to group them into various different clusters. All right. Okay. The next kind of sampling is known as segmentation sampling or segmented sampling. So let's just quickly move to the next slide. Yeah. So here you now I'm going to give you an example. Suppose we want to study the spending and buying habits of people who wear medium and large clothing sizes. Okay, here we have people of different sizes, and we're going to arrange them by height. Okay, and that's going to look as follows right here. Now what I'm going to do is I'm going to choose the middle segment of the population that I want to study. Now if I'm trying to study spending and buying habits, logically speaking, the height of a person should not affect their income. Secondly, it should not affect their spending habits. So what I have done here is arrange them by height and then pick the segment I want to study. When we use segmented sampling, it is very important to ensure that we do not pick a variable to segment on, which could possibly affect the variables that we are trying to study. All right. So here, because we can say that the correlation between height and spending habits is nearly zero, height is a safe variable to pick. All right. Okay. Now, how is this different from clustered sampling? Clustered sampling tries to arrange samples into groups based on any of their properties, based on their overall properties, whereas segmented sampling picks one property or one variable and then segments them out or separates them into groups. All right. So these are the 4 basic kinds of sampling. Now let us look at the final kind, which is basically a hybrid of the other kinds of sampling, and that is going to be complex sampling, which is basically a combination of other types. Let's go back to our apparel example. Our company wishes to study the spending habits of people. This time, we are once again going to order them according to their size, and then we are going to take a median group, right? But we are going to go a step further. We are now going to cluster them on the basis of gender. So now we have 2 clusters, one of men and one of women, because logically speaking, we can assume that men's spending habits and women's spending habits when it comes to apparel will be slightly different. And therefore, we study these 2 groups independently to get a better idea of what is going on. Right? So these were the different kind of sampling methods. But as I mentioned briefly earlier, these are all prone to some kind of error or the other. And let us look at the different errors that can creep in when we are sampling. So there are 5 main kinds of errors, basically population specification error, sample frame error, selection error, non-response error, and finally the sampling error. Let's look at the first one very quickly. So population specification error is basically when you are not sure which population segment to target, right? Let's take an example of where a data scientist wants to find out about why people prefer a certain console over another. So he starts asking questions at the cashier's desk of a popular gaming store. A customer wanting to buy a certain gaming console A comes up to the cashier's desk and we ask them why did they choose gaming console A over B? And this person simply responds that they heard it is better. So in this case, however, the decision of this person to buy gaming console A over B might in fact be influenced by their kids for whom they are buying the gaming console or a friend or whoever it is. So in this case, it might be better for the data scientist to target the children directly and ask them why do they believe that gaming console A is better than B, and then get a more accurate and a more in-depth result of understanding of the question that they're trying to study. That is population specification error. Next, we have what is known as sample frame error. Now, this is prone or can happen with segmented sampling. This happens when you select a segment which is not really representative of the population, right? So, in this example, our data scientist is trying to find the effect of oil prices on consumers. So, what happens is they decide to focus on people who recently bought a car to get an idea of how the oil prices are affecting them. And let's just see what happens here. So you ask them, what do you think of high oil prices? And they respond saying that high oil prices means more profit, which means it's good for the economy. And that's generally seen as a good thing. Now, because we have targeted people who recently bought a car, it might be that these are the people who are already well off and who are able to buy a car. We are ignoring a very large part of the population who might not be able to purchase a car in hard financial times and might be hit very hard by the high oil prices. This is sample frame error, where the frame you choose, the segment you choose, is very different from the actual population and does not represent it accurately. All right. So let's move on to the next kind of error, which is selection error. Okay, now this happens when only people who are interested respond. So when you leave it open to people to choose whether or not they respond, this kind of error can creep in. So in this example, our data scientist is trying to get an idea of the quality of a recently opened burger joint in the neighborhood, right? So he sets up shop outside and would like to get people to answer a few questions. But this happens. The satisfied customers are happy. They're just going about their day and they decide to get a move on, right? But as we have seen on various online websites like Yelp and Booking.com, a lot of negative reviews come in there because when people don't have a good time, the first thing they want to do is make sure the whole world knows about it. And so this person has come to our data scientist and is complaining about the absolutely abysmal service that he has received, right? Now, what has happened is that it has skewed our results because we are only targeting, or the people who respond to us are skewed towards a certain spectrum of opinion, right? Now, this usually happens, like I said, on online rating websites, or if we ask people about something obscure and people only that are interested in that thing will tend to respond, right? So how do we correct selection error? This is basically by incentivizing people to respond to your survey or to answer a few questions and through a lot of follow-up, right? So this is done usually in the form of rewards or incentives, or yeah, some sort of small free gift to people who answer the surveys. And this is nowadays seen quite commonly online. Let us now move to non-response error. Non-response error is when you reach out to people, but only a section of them respond, and the people who do not respond are significantly different from the people who did respond. In this example, our researcher has contacted a lot of people to see whether they support the blue team or the red team. And somebody comes in and they are going to say that they support the blue team, right? But the thing is, a lot of the people had probably other things on their mind and did not have the time or the energy or the interest to respond to your survey, or they declined to respond to your survey, right? So this is one example of non-response error. And where does this occur in real life is generally when you try to survey a population. It was usually found that the working class tends to not respond to such surveys or declines from responding to such surveys. How do we correct this is by trying to follow up with this population that did not respond through alternative means and try to find out why it is that they did not respond or how we can incentivize them in the future, right? So yeah, this is basically an example of non-response error where the people who did not respond in this case clearly supported the red team instead of the blue team. All right. Now let us finally move on to the final kind of error, which is sampling error. So as I mentioned earlier, sampling error can occur when we are talking about random sampling and we do not take enough number of observations in our final sample. Let us see how that happens in this population right here of 10 people. 5 different groups and 2 genders, right? So I'm going to pick 4 people at random. Okay. Right away, you can see that there's a small problem with the sample we have selected. The first being that we don't have anyone from the yellow segment, right? So the yellow segment is not at all represented in our final sample. Secondly, the sample that we have selected has got 3 women and 1 man, whereas in the actual population, the split is 50-50, which means men are underrepresented and women are overrepresented in our sample. How can we fix this? Just make sure you draw more samples, or you can use a complex method of sampling where perhaps we could have segmented them according to their team or their color, and then focus on each segment, maybe perhaps on the basis of gender and so on and so forth, and then study each group individually. But this is basically an example of sampling error where we have tried to use random sampling on a heterogeneous group where there is no homogeneity. All right. So these are the different kinds of sampling errors which can creep in with sampling, and the different methods that we have used. Once we have a sample, it is now ready to be explored for the data. Right? But how we actually go about that is going to be discussed by my colleague Samir. So I'm going to now hand it over to Samir. Samir, take it away.
Thanks, Pratik. So as we said, once you complete the data sampling process, the next step is to explore your data. So the first question is, what is data exploration? As the name implies, data exploration is the preliminary examination of your data so that you can better analyze and understand what your data might be telling you and use that to inform the analytics and visualization methods and solutions and models that you should consider using. Generally, this is done by utilizing visualization methods such as Tableau or Power BI in order to look at your data and be able to spot any issues or concerns that you might have so that you can make those changes and correct those possible errors when it comes to the later phases of the data wrangling process. So data exploration on the whole allows you to accomplish 4 basic tasks. First, it allows you to find the general trends that are true about your data. Second, it allows you to spot the outliers that are in your data set. Third, it allows you to spot the inconsistencies and garbage values of your data. And fourth, it lets you examine if the assumptions for the model are satisfied. So let's take a moment and explain kind of why these 4 steps are important. First, finding the general trend allows you to better understand what correlations between dependent and independent variables there might be, which allows you to plan which models you want to use. Spotting outliers will allow you to better understand what data points might be causing a skew in your models in the future so that you can identify and potentially remove them from consideration. Spotting inconsistencies and garbage values will allow you to understand how you need to refine your data set. In a lot of ways, the adage that data is the new oil is very true. Oftentimes people use that, admittedly, to say that data is valuable and that it adds worth to your organization's processes. However, data is also like oil in that you must refine it. If you take crude oil out of the ground and try and put it into your gas tank, it won't actually get your car to work. You have to turn it into petroleum or kerosene for it to be of any use to your purposes. The same is true for data. Finally, you have to be able to examine if the assumptions for your model are satisfied. For example, you want to be able to know in this example whether the linear model is good for your data. The linear model might pass the circle and triangle test, but unfortunately you may find that a lot of your data is pentagons that are trying to go into star-shaped holes. So let's hop a little more into what methods of data exploration you can utilize. 2 of the most common visualization methods are to take a discrete variable, such as the frequency of purchases made by your customers, and split your data into columns based off of that frequency. The other option is to use 2 continuous variables, such as attendance and marks, in order to create a scatter plot. You can then take the data that's in your scatter plot and group them by the different clusters of variables not considered on the X or Y axis, and can use that to inform your considerations on what models to use. Let's go into a little more detail about each of the 4 value points of data exploration. First, let's start with finding general trends. Here we have the example of pipe fittings that are utilized for building houses. These pipe fittings are demarcated by the diameter of the pipe as well as the height that the pipe can reach when laid vertically. As we can see, we find that there is a general trend where as the height of a pipe increases, the necessary diameter also increases. Now, granted, I'm not a master at physics, but I assume this has something to do with the flow of fluids. But being able to identify this general trend does allow you to better plan out what models might be good for drawing assumptions or planning analytics about your data. The other function is for spotting outliers. Suppose that we have this same data set. Now, initially, when we put the line of best fit, it might be skewed. Now, initially, this will look fine, but the problem is that upon closer inspection, we realize that this is not a correct line of best fit for our data, in large part because we have this outlier that is so far in diameter versus height that it's actually causing our model to create an incorrect line of best fit. If we ignored that outlier, our line of best fit would be much more accurate and would be better representative of what we want to find in terms of modeling choices. We also want to be able to spot inconsistencies in garbage values. Let's take the example of this data that we received for first quarter sales from our sales associates. We have all of the columns that we might want to consider, the first and last name of our different sales representatives, their sales by month, the total sales that they made each quarter, and the region that they are working in. All of these are important information for us, but we might notice some issues when we take a closer inspection. For example, on one of our values, instead of north being spelled N-O-R-T-H, it's being spelled N-O-R-H-T. This minor misspelling actually causes an error when we go to try and cluster our data, because suddenly instead of the 4 regions that we're using, north, south, east, and west, we now have 5, north, south, east, and west, and also north, which we don't need and doesn't actually make any sense. Being able to identify these types of errors allows us to correct them during the later phases of the data wrangling process and prevent embarrassing mistakes like this from happening in the future. Let's take a real-world example. Suppose that we got a survey from a parent survey on gifted and talented students. We might notice that there are some issues of inconsistency with our data. For example, some of the parents did not actually give the school district that their student is currently in. Not having this data means that we don't know how to track which school districts are doing well in terms of performance on these exams. We might also notice that there's an inconsistent date format. While most of the parents only gave their students score out of the total, some actually also listed the total. This inconsistency in data might cause errors and make it difficult for us to perform analytics. Third, there's an inconsistency in how data is entered and evaluated in the school preferences column. Some users are only entering the name of the schools that they care about, whereas others are giving a commentary, such as how they would likely stay in the zone schools for their student's current district. All of these are points that we need to be able to identify and plan to either fix or remove. We can also utilize data exploration in order to identify if our assumptions are correct. This is done mostly by being able to parse through all of our data and find patterns or issues that might be of concern so that we know which data is good to use and which ones aren't. Let's go back to that example that we had of gifted and talented students. We notice a couple of important things upon closer inspection of our data set. For example, most of the applicants have children that are in kindergarten. This means that a large amount of our data will be about kindergartners, and that might skew our data when considering first graders or second graders, which we do see we have a couple of entries for. So we need to keep that in mind. Second, we notice that the majority of students who have reported their scores were in the 99th percentile for the NNAT's non-verbile percentile. This is important to consider because this means that if we tried to use this percentile to view our data or to model our data, we would have a clear skew where the vast majority of students would be in this 99th percentile, which means that all of the other users might be considered outliers when that isn't actually accurate. The third thing we might notice is that many of the applicants are born between December and March. This might allow us to make the realization that we might want to consider a model that allows us to take birth month and compare that to the percentile of the student on the OLSAT and the NNAT, as this might find a correlation between the student's age in their general cohort of school year and how well they performed on these exams. And that allows us to plan the models that we want to utilize. Now, granted that a lot of this is very dense, but being able to keep all of these in mind allows us to plan our model and how we want to do our data analytics in the future after the data wrangling process is complete. So, in summary, data sampling allows us to select smaller data sets from our whole to allow for faster analytics. It consists of 4 types of sampling methodology as well as complex sampling, which is a composite of the other 4 methods. There are also 5 major types of sampling errors that we want to consider and avoid so that our data set is relatively accurate. Data exploration is the preliminary examination of our data so that we can spot trends and outliers that stand to affect our data, as well as identify the junk data entries that might need to be corrected or eliminated. So I think that brings us to the end of the content that we wanted to share with you today. Pratik, why don't you let everyone know a little more about how they can reach us if they have any questions.
Yes, indeed. Now, naturally, sampling as well as exploration isn't as straightforward as it seems here. There's actually a lot of analysis that needs to be done, a lot of decision making that needs to be done beforehand, and sometimes it's not a very intuitive process. But in case you have questions, then feel free to reach us at the email IDs on your screen right now. Or if you would like help with your data wrangling process, or if you're an organization that does not already tap into the data that you have of your users and would like to know how, then please definitely do get us in touch, and our team of experts will be happy to assist you in the same so that you can unlock the potential of your data and improve the performance of your organization by a great deal. So do let us know if you have any questions, any feedback at the email addresses below. And with that, we would like to conclude this webinar. Thank you all for coming, and do join our webinar on the 11th of May on data cleansing and on the 14th of May on data modeling. We hope to see you there. Bye-bye.
Bye-bye.